Hey, Mr. Harridan here. We're going to go over dissolving equations and I. Okay? Now, the first thing we really have to understand here is there are no diatomic ions. That is a common misconception here. There are diatomic elements, but there are no diatomic ions. Okay, so soluble ionic compounds will completely dissociate into ions when they dissolve. We show this in the equation for the process. We will show the dissociation with a one-way arrow. A one-way arrow means it is 100% dissolved. Okay, so for instance here, sodium chloride is aqueous. So it will break apart into sodium ions and chlorine ions. Okay? In a sodium chloride solution, there is 0% of sodium chloride. There is 100% sodium ions and 100% chlorine ions. Because for every sodium chloride, we get one sodium and one chloride ion. Okay? But the big point here is there's no NaCl flowing around. It's all Na pluses and Cl minuses. Okay? Polar covalent compounds dissolve, but they did not dissociate into ions. Okay? For acids and bases, strong acids and bases completely dissociate 100%. When it's 100%, that means there is just one arrow. It completely dissociates into ions, and we show this with a one-way arrow. Weak acids and bases partially dissociate, so we show them with a double arrow. Okay? You do not need to memorize the list of strong acids and bases right now. You will next chapter, but the strong acids are HI, HBr, HCl, HNO3, H2SO4, and HClO4. The strong bases are OH minus with group 1 metals or group 2 metals except for Be and Mg. Okay? All other acids and bases are weak. Okay? So for example here, HCl is a strong acid, aqueous. It dissociates into hydrogen ions and chlorine ions. Notice that they are not diatomic. Okay? Which means that there is 100% H plus in these and 100% Cl minuses, but there is 0% of HCl and HCl, believe it or not. I know. Same thing for calcium hydroxide here. This is a strong base. It's in group 2. Calcium's in group 2. So we have 100% calcium ions and oh my goodness, plus, what the heck? -1 for hydroxide. I got my hydroxide paper, right? OH minus. Anyways, I'll fix it eventually. Okay, so that is -1 here, so and there's 100% of those too. And no calcium hydroxide. Same thing for sodium hydroxide, 100%, 100%. HF, hydrofluoric acid. It's the greatest way to throw diamonds from cubic zirconium. It's very dangerous though. I used to do that. Notice that this has a double arrow. So we have some H pluses, some F minuses, and some HF in there. Okay? Because it goes back and forth. The reaction goes back and forth because this is in equilibrium. Which means it goes at equal rates. Okay? These amounts are not equal, but the rate of the reactions are equal. That's the key about equilibrium. Okay, going on to the next page. Page 7. Okay. Okay. We will use the symbol I, lowercase letter, to indicate the number of particles formed when a substance dissolves. Acids and bases and ionic compounds, the number of i's will be formed during the dissolving process. Polar covalent substances dissolve in water, but they do not dissociate when they dissolve. Okay, we're going to fill in the following chart. Let's see if we can get the whole chart on the page. first to ammonium chloride. Okay, notice I changed this to sulfurous acid here. Okay, so the first thing you have to do here is figure out if these are acids, bases, or ionics. Okay, remember acids have the word acid in it. Acid, acid. Okay, bases, you're looking for the OH minus. Lithium's a metal, so this is ionic. Don't you think? Calcium is ionic. Magnesium is a metal, makes it ionic. Aluminum is a metal, ionic. Copper, metal, ionic. Because remember, ionics are between a metal and a non-metal. And ammonium is a polyatomic ion. This is ionic as well. Okay, let's go to our acids here. Nitric acid is on the strong acid list. Okay, so is it soluble in water? Yes. Sulfurous acid is an acid. All acids dissolve in water, so this is a yes. But it is not on the strong acid list. This is actually a weak acid. Strontium hydroxide is a strong base. And it does dissolve, yes, according to our solubility rules. Okay, so now to figure out the other ones here, we got to look at these solubility rules. Here, solubility rules. Come out, wherever you are. Okay. So lithium phosphate. Lithium is in group 1, so it is soluble, so this is a yes. Calcium sulfate. There is a rule for sulfates. Calcium's on the other side. This is an S, so this is not soluble in water. Magnesium chloride. There is a chloride rule. Magnesium is not on the other side, so this is yes, soluble in water. Aluminum perchlorate. There is a perchlorate rule. There are no exceptions, so this is a yes. Copper 2 iodide. There is an iodide rule. Copper is not on the other side, so this is a yes. Ammonium chloride. There is an ammonium rule. There are no exceptions to that, so this is a yes. Okay. Okay. Phosphorus tribromine here. Phosphorus is a non-metal here, so this is actually covalent. Methane is covalent as well. Remember, to figure out if these are soluble, you have to draw the Lewis dot structures. Okay? So for phosphorus tribromide, you have 26. Remember, you bond your 3 bromines first. 1, 2, 3, 4, 5, 6 pair, 7 pair, 8 pair, 9 pair, 10 pair, 11 pair, 12 pair, 13 pairs. Because 26 divided by 2 is 13 pairs. Okay, that's how I got that really fast. So this is actually polar, so this is actually, yes, it's soluble. Methane, this is 8 divided by 2, so I need 4 pairs. This is a C bonded to an H, bonded to an H, bonded to an H, bonded to an H. This is nonpolar, so this is not covalent, so it's no. Okay, now we get to the dissolving equations here. Back to the top here. Nitric acid. Remember, this is the acid of nitrate. Okay, so we have HNO3, which is aqueous. This is a strong acid, so this is a one-way arrow like that. What 2 ions is nitric acid going to dissociate into? H plus and NO3 minus. These are both aqueous. So this is 2 ions. Sulfurous acid. Sulfurous acid is the acid of sulfite. Sulfite is SO3 2 minus. So this is H2SO3 aqueous. Now this is a weak acid, so you need the arrows that go back and forth because this is in equilibrium. What ions is this going to separate into? H plus and SO3 2 minus. Now there's going to be a big 2 in here because this is not a diatomic ion. 2 plus 1 is 3 ions. Okay, strontium hydroxide. Strontium is plus 2, hydroxide is minus 1, OH, SR. So this is SR parentheses OH2, and it is aqueous according to the solubility rules. Plus it's a strong bases are aqueous. So this is going to be a 1 arrow right here. So what 2 ions am I going to make? Strontium and hydroxide. Strontium is plus 2, hydroxide is minus 1. There are 2 hydroxides, so I need to put a 2 out here. I gotta keep putting these aqueuses on my ions. I always forget those. Because all ions are aqueous. So this is 3 right there because it's 1 from the coefficient here and 2 there, so that is 3. Lithium phosphate. Lithium is Li, phosphate is PO4, minus 3 plus 1. Li3 PO4. This is aqueous. It separates into lithium and phosphorus. Phosphate, Mr. Harridan. Phosphate. Ions. Polyatomic ions stay together. There are 3 lithiums here, so you need a big coefficient of a 3 there to balance out the charges. 3 plus 1, 4 ions. Then we get to calcium sulfate. Calcium sulfate is a solid. So this is CaSO4 solid. We will not write a reaction for this one for now. In AP you will. Okay? But there is no reaction for that. Okay? The number of okay, so this to me is 1 particle because it did not break apart. Okay? Some other people might disagree with me there, but yeah, that's what I'm going with. Okay. Magnesium chloride. I should have told you calcium was plus 2 and sulfate's minus 2. This is Ca and this is SO4, right? Magnesium chloride. This is plus 2 and this is minus 1. Mg and Cl. So this is MgCl2. It is aqueous because it is soluble. So this is going to break apart into magnesium and chloride ions. There are no diatomic ions, so you have to put a 2 here. 1 plus 2 is 3 ions. Aluminum perchlorate. Aluminum is plus 3, perchlorate is minus 1. ClO4 Al. So this is going to be Al parentheses ClO4 3 aqueous. This is going to break apart into aluminum and perchlorate ions. Aluminum ion is plus 3. Oh my goodness, I'm forgetting my aqueuses. Aqueous here, aqueous there, aqueous everywhere. If it's an ion, it is aqueous. And my perchlorate ion, which is aqueous. There are 3 perchlorates here, so that now becomes a coefficient. 1 plus 3 is 4 ions. Copper 2 iodide. Copper 2 is plus 2. Iodide is minus 1. This is Cu and this is I. So this is CuI2, aqueous. Breaks apart into copper 2 ions and iodide ions. There are no diatomic ions, so I need a 2 in front of that because I have 2 iodines over here, so I have to balance out the equation. 1 plus 2 is 3 ions. Ammonium chloride. Ammonium is +1. Chloride is -1. This is NH4 plus. This is chloride is Cl minus. NH4Cl aqueous. We're going to break this apart into NH4 plus and Cl minus. I still need my aqueuses everywhere. Aqueous here, aqueous there, aqueous everywhere. Okay, that's balanced because it's plus and minus. Because the total charge over here has to be 0 as well. That's the other thing I'm checking. I'm checking the atoms and the charges. Like here, +2 and 2 minus 1 adds up to 0. So that's how I know I have 3 ions. Okay, so this is 2 ions, +1 and 1 right there. Okay, now we get to phosphorus tribromide, which is soluble. But remember that this is covalent. This does not break up into ions. So this just stays PbR3 aqueous. Okay? And this is one particle to me. To dissociate, you have to have ions, right? It has to be ionic, acid or base, and it has to be soluble. Here it's soluble, but it's not ionic. And then this one right here is not even soluble, so there is no reaction here. And I'm going to put X's here. Okay? You guys are champions. The legend is